Was the Boeing 747's hump structure a necessity, or was it a race among airlines to attract attention? Was it really possible for passengers to sit further forward than the pilots? In 1966, Boeing took the biggest corporate risk in aviation history by investing all of the company's capital into this massive aircraft project, which was considered impossible to produce. The scale of the project required assembling 6 million individual parts, laying 274 kilometers of cable, and making 75,000 engineering drawings without a single error. Since there was no indoor building in the world at that time large enough to assemble such a huge aircraft, Boeing started from scratch in Washington state and built the Everett factory, the largest building in the world by volume. The engineers and workers, who called themselves the Incredibles, assembled the aircraft in this factory, where even the roof was not yet completed, in the freezing cold. If the project had failed, the $1 billion spent, approximately $9 billion in today's money, would have completely bankrupted the company, because this amount was even more than Boeing's total net worth at the time. But this is where the most exciting part of the story begins, because this massive industrial gamble would reshape global civil aviation. So, what kind of innovation did this bold move initiate in aviation history? The aerodynamic design of the Boeing 747 was actually built on a strategic technical foresight that the main market would evolve into cargo transportation in the future. The iconic humped structure, which is the most prominent feature of the aircraft, was not designed for passenger comfort, but as an operational necessity. Engineers moved the cockpit to the upper deck so that the nose of the aircraft could open as a cargo door. This mandatory design decision prevented the cockpit from obstructing loading operations, thereby maximizing the aircraft's cargo capacity. However, this technical adaptation created a design anomaly in civil aviation that offered a unique travel experience in the nose of the aircraft, where passengers could sit ahead of the pilots. Beyond being an aerodynamic signature, this hump is the most tangible proof of the aircraft's versatile industrial design philosophy. In addition to the aircraft's shape being different from other planes, its flight performance had to be just as good. The flight performance of the Boeing 747 was optimized to push the boundaries of subsonic flight, competing with the speed of supersonic aircraft designs of the era. With its 4 high-bypass turbofan engines, capable of reaching a cruising speed of 564 miles per hour at an altitude of 10,000 meters, the 747 still holds the title of the fastest wide-body passenger aircraft in the sky. With the help of wind currents, this massive machine broke the fastest subsonic flight record in civil aviation history in 2020, completing the New York-London route in just 4 hours and 56 minutes, nearly approaching a supersonic speed. Within the technical limitations of the 1960s, the fact that this machine, designed with computerless calculations in simple wind tunnels, outperformed its modern computer-aided competitors in speed performance is the pure pinnacle of engineering. Produced with 1960s technology, where most things worked mechanically, this aircraft represents the pinnacle of analog engineering, requiring a tactile connection and complex orchestration for pilots. When the aircraft first entered service, there were exactly 971 mechanical switches, gauges, clocks, and warning lights in the cockpit, and each of them was of vital importance. At that time, in the absence of autopilot and digital systems, the captain pilot, co-pilot, and flight engineer had to work in perfect harmony to keep this mechanical monster in the air. The flight engineer manually adjusted fuel transfers, electricity generation, and the hydraulic balance of the engines from a massive panel. This analog control panel gave pilots a sense of directly touching the aircraft's systems, and the sound of each switch allowed the pilot to feel the change in hydraulic pressure in their hands. Flying the Boeing 747 was not just a profession, but a pure form of executing analog engineering. The humped structure may provide the aircraft with an incredible aesthetic form, but this hump is a section made out of necessity. The chief engineer of the aircraft, Joe Sutter, had actually imagined a completely different monster in his mind. Sutter wanted to build a massive aircraft with 2 full decks extending along the entire fuselage. However, the strict safety rules of the Aviation Federation prevented this technical design. According to the rules, in an emergency, all passengers had to evacuate the aircraft in just 90 seconds. When the engineers realized that it was impossible to evacuate people from a massive double-deck fuselage in this time, they had to scrap the project and start all over again. It was this safety dilemma that gave birth to the aircraft's noble humped structure today, a design that limits the upper deck to the front section only. This mandatory design change did not only add aesthetic beauty to the aircraft, but also provided an incredible logistical flexibility that extended the aircraft's lifespan by decades. The 747s retired from passenger transport were converted into massive cargo planes by fully opening their noses, thanks to those high cockpit designs, and they continue to serve in the skies. If you like our videos where we explain the working principles of airplanes and the world's largest machines with simple 3D models, don't forget to subscribe. The challenging mission that started in 1966 progressed by becoming harder and harder every time. In 1989, Qantas Airways decided to carry out a flight that had been considered impossible until then. The goal was to fly non-stop and continuously all the way from London to Sydney, for a full 18,000 kilometers. The Boeing 747-400 model could carry 240,000 liters of jet fuel in its massive fuel tanks. However, even these massive tanks were insufficient for this ultra-long distance, so engineers stripped all unnecessary weight inside the aircraft and placed additional fuel tanks in the cargo compartments. The aircraft remained in the air for a full 20 hours, and when it touched down in Australia, there was only a critical amount of fuel left in its tanks, enough for just a few minutes of flight. This achievement was a massive technical demonstration that proved to the whole world what could be accomplished with 1980s technology, a full 20 years before modern ultra-long-range aircraft were produced. Given new missions continuously from its first moment of production until today, another interesting mission of the Boeing 747 was to help NASA. For a full 30 years, NASA used two specially modified Boeing 747 aircraft to transport space shuttles between launch and landing sites. We are talking about mounting a 78-ton massive space shuttle onto the back of a passenger aircraft and flying it safely in the air. NASA engineers stripped everything inside the aircraft, reinforced the fuselage with steel bars, and placed additional vertical stabilizers on the aircraft's tail to balance the massive air turbulence created by the shuttle behind. No other commercial passenger aircraft in the world had a fuselage structure strong, flexible, and immense enough to take off and fly with a 78-ton aerodynamic load on its back. When the Endeavour shuttle was moved to the museum for the last time in 2012, two great icons of American engineering history rose on each other's backs, closing an era. This humped structure, which emerged because a very special project was changed due to non-compliance with regulations, has determined the entire career of the Boeing 747. In addition to offering a very aesthetic appearance that distinguishes the aircraft from other planes, it has allowed it to perform many different missions after retiring from passenger transport duties. The Boeing 747 is one of the most iconic and important engineering monuments in civil aviation history. It is not just a technological tool, but a pure form of executing aerodynamic design, industrial engineering, and civil aviation culture. Today, while boring twin-engine aircraft designs that are based on algorithms, fully focused on fuel efficiency, and look identical to one another take over the skies, the magnificent and noble stance of the Queen represents the golden age of aviation. It has shown all humanity that a machine can be both aesthetic and extremely useful. The Boeing 747 proved to us that engineering does not consist only of cold mathematical equations, but can also be aesthetic works of art that lift the human spirit and imagination into the skies.